Hello, this is Barry, G8AGN, and I'm with Bob again at the Finningley Amateur Radio Society, and we're doing a test today on an Arduino controlled mirror source. So although what you'll be able to see is the sunlight reflecting visible light towards me, but what we're really picking up in the receiver itself is the infrared signal which is being reflected from the sun via the mirror. As you can hear now, we're getting a very strong signal. At the moment we're only probably about 50-60 meters away. This is the first time we've tried the mirror out, so we're having to go onto a learning curve. So what we'll do is we'll go down to the other end and have a look at the mirror. Bob is trying to align it at the moment. Well, it's easy to align now because it's fixed on a tripod. But the thing we have to remember is, of course, that as the sun moves around, the reflected signal from the mirror will also move. So eventually we'll have to have a way of compensating for that. Well, I'm now down at the other end of the link, and we're now showing the mirror reflector, which is actually being modulated at the moment. So the Arduino is actually tilting the mirror to send slow morse, QRSS 1, so that's a 1 dot second time. So if we just move in, you can see the mirror actually moving. It sounds like an old-fashioned pendulum clock when it's moving. So this is the rear side of the mirror, just showing you the actuator, which is just a small solenoid, which is pulling the bottom half of the mirror back when it's in the key on position. We're now looking again towards the receiver dish, and you can see that every so often the dish is illuminated by the visible light reflected from the mirror, but of course the receiver itself is only responding to the infrared, the 30 terahertz radiation which is reflected off the mirror from the sun. Notice there's quite a long time delay between the mirror being in the right position and flashing light before the sensor actually responds to the infrared signal. So that's the sensor time constant, presumably. So it's almost a second afterwards. It sounds as though the leading edge of the pulses is much sharper than the trailing edge of the pulses from the transmitter, and that must be to do with the mechanics of the way that the mirror is being tilted by the solenoid. So we're now at 130 meters across the Finningley field. noticed a slight time lag between the sensor responding to the signal from the mirror and then the overshoot at the end when the mirror is turned off. Nevertheless, that does seem to be working well now. Alignment is very critical though, and this is not helped really by the fact that of course the sun is moving across the sky at a very slow rate, but after a minute or so we then have to realign the mirror to make sure that it's now pointing again, or the reflection from the mirror is now pointing again at the receiver. So we can see at the moment that we've lost that consistency. It's just a pause again between. See, we've lost it now. Threshold adjustment is quite critical, and this is why we are getting some misread characters at the moment. It's the signal which is reflected off the ground. This is the problem. I've now readjusted the threshold on the receiver, and obviously I've gone a bit too far now. So this is the problem we're having now. At this distance, both the transmitter and the receiver are not that high off the ground, and so we are getting a signal which is reflected off the ground, as well as the signal coming directly from the mirror to the receiver. Dash, dash, dot, dash, 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 dot, dot. At times there's quite a long delay with the signal going off after the mirror has obviously gone into its key down position. Again, we seem to have lost the... It's probably because the sun has moved around slightly and the mirror is no longer exactly aligned onto the receiver. I think Bob is... There we are. Bob is obviously taking the opportunity to realign the mirror. There we are. You can see when it's on us that we're getting extremely strong signals. In fact, the light from the mirror, the visible light from the mirror is very hard to look at. It's so bright. So the signal's quite consistent once we've got the alignment correct, but what we need, I think, is some means on the mirror of tracking round in azimuth to follow the sun. Obviously it won't follow the elevation change of the sun, but I think that probably is a bit less important than the azimuth adjustment. So this is quite consistent now. Again, there's another long pause between words. It sounds as though it seems to go on forever, but it's actually 7 dots worth. Now it's not quite as bright now, so the sun has obviously moved around very slightly more, so the mirror alignment is not quite as good as it was before. But having said that, the signal strength on the meter still seems to be comparable with what it was before. So this is looking quite hopeful. Finder. So we're now back at the transmit end, just watching the mirror tilt backwards and forwards, and the receiver is right over the other side now. I can see it in here. I can see the dish brighten up.
Yeah, good. I think we've reached the end of the sequence then.
Yeah.